Thank you. I offered the previous speaker 1 minute additional time for every reference he would make to the Quantum Application Lab. So that's well appreciated, but it also means that I have somewhat less time. Okay, there I should look. So this morning we've heard a lot of talk about exponential growth and what qubits hope to achieve. And that brought me to the notion of the second half of the chessboard, something to visualize the power of exponential growth. And it's easy to see how that would scale. So while the first half of the chessboard is already a large amount, the second half is vastly larger. In fact, so large that you don't need multiple chessboards to represent how much that actually is, but you would need something of the size of a bulk carrier in this sense, the largest vessel that's out there, and not just one, but over 1 million, just to have that representation of 2 to the power of 64. And then probably everyone in this room will know that if in that comparison or analogy towards qubits on a chip, you would add 1, here, of course, you would then add another 1 million of those bulk carriers for the amount of grains of rice that represents actually that amount. So I guess I'm sort of the person that wants to visualize how much that actually is, and we see every day the amount of publications that have like dozens of digits towards the potential compute capability of quantum. This powerful notion brings me to the introduction of the Quantum Application Lab, in which we develop applications for quantum computing. And if there's one slide that would help me explain what we do, it's this one. It's hopefully not just a bunch of logos out there, but actually there's a structure. I'd like to explain briefly. The Quantum Application Lab Consortium is founded by not-for-profits that combined have software developers, have engineers, architects, but also consultants and project leaders to then ultimately take on that challenge of application development. We work with industry and sort of the supply side, hopefully with all and any leading qubit technologies, also including HPC, to be fair, because ultimately for end users, these are all compute capabilities that they want to deploy for building useful applications. And then all the way at the top, you can see participants. You could consider them clients, but we actually prefer the word of participants in R&D collaborations. And you can see there's multinationals, there's corporate, there's utilities. Essentially, there's all sorts of participants that are looking for know-how, for tooling in the area of optimization, simulation, machine learning, for applications like clustering, ranking, sampling, search, augmentation. And what I'd like to do in this very brief talk is just highlight some applications. Not so much to spend a lot of time on what it is that we've done, but much more how we've done it. One is in agri and food. There's this concept of genomic selection. You can do this for animals. You can also do it for plants. In plants, you would be looking at crop science applications. With animals, it's more about animal breeding. And here we developed randomized algorithms for single value decomposition. And we found that by reducing the dimensionality of genetic data sets, large genetic data sets, we found a computational process that is sped up while preserving the accuracy of the machine learning models. Another use case is in energy. Last year, I presented the N-1 case, which is about grid reliability, something that industry is very much familiar with. And here, in this particular case, we took a look at state estimation, power flow analysis, and we discovered various techniques that could be beneficial for the process of solving linear systems and equations. One of the things we took is the algorithm for solving Now I forgot the solving of the sparse matrices. And one piece of the feedback that I found very helpful is that this end user in the energy space have valued the collaboration as something that helps them to support the speed up of the digital and energy transition, much more than the speed up of the technology itself. They felt that the collaboration was helpful and instrumental in their strategic goal for speeding up the energy transition. And then lastly, one case in healthcare, something that is actually quite close to my heart in radiotherapy treatment planning. Here this collaboration just ended. We are still in the process of wrapping up the results and soliciting input. But here we have identified that the algorithm, which is fluence map optimization for photon intensity images, was a bit too complex for where quantum currently is. Still, the organizations that we have worked with, in this case, University Medical Center in Utrecht and Electa, are looking to find a suitable follow-up by taking a slightly different approach. And so that's quite helpful. Now, all of these examples have probably an audience of just one, meaning that an application is very difficult to make generic and scale beyond that individual project. But 5 key insights I'd like to share with you briefly that make this much more of a capability rather than a one-off. First, I'll start with the why to the how. If you would approach end users around their computational constraints in classical workflows, I find that all of them are open exploring if and how to use quantum. So it's really not an issue for me when talking with end users to explain why we need quantum. It's much more a question about how do we do this. Then second, I would say it's getting from feature to value. What my feeling is about quantum is it reminds me of the market of power tools, which is the image on the left. Typically, you sell this on features. I see this also with other technology and as we're talking about today, also with quantum hardware. But typically, end users do not really want a power tool. What they need is a hole in the wall. In fact, they don't even need a hole in the wall. They want to hang a nice picture or a painting, in this case, from the mission here in Santa Clara. So as much as I appreciate the fact that you want to use your specifications and your requirements, it's also helpful to understand that end users typically want to know how that relates to the problem they want to solve. Then third, as a countdown, also looking at the time from the work so far, we see that the future will be hybrid and not all problems need quantum. Of course, it's easy to appreciate the golden chandelier, but ultimately end users will want workhorses. Then the second last one is applications require collaboration. So there's no way you can assume that your hardware will automatically work. In the example of radiotherapy treatment planning and the sort of the class of the fluence map optimization algorithms, here you can see that there's a certain part in the optimization approach that needs very much the involvement of subject matter experts and data sets that are specific to a department. Here you see OAR, organs at risk. You can easily see that within a single hospital, for each of the specialties, if you like, all of the treatments, you will have different dynamics around just one of those components. So please make application development a collaboration which you have really engagement and involvement from the end user. And then last, practice makes perfect. We see that also knowing there's no fault-tolerant quantum computer, also knowing that NISQ applications may not represent the same value as quantum fault-tolerant. Still, there's a lot of lessons to be learned. And in this case, we've done something in bathymetry, which is using satellite data for estimating water depth, and we improved a classical subroutine in an algorithm that is already being deployed now. Now, that could be something that a physicist or a sort of a quantum hardliner would say, well, actually, that's not quantum. Still, who am I to sort of blow against the wind if an end user would say, okay, this is interesting, we want to do a follow-up, and I'm happy to also invest in cash in kind for this. So that, to me, is a very important part of feedback to keep on focusing on application development. And with that, I slightly run over, but thank you for your attention. If you're interested to hear more about the other applications we've developed, feel free to reach out. Thank you.